Welcome to the Specialty Crops Suitability tool. This tool was created to provide a general overview of crop suitability, phenology, and irrigation needs for selected high-value perennial specialty crops in the Northwest. The tool uses phenology-based crop suitability models to provide an estimate of the percent of years, or number of years out of 10, that a selected crop may successfully reach maturity for each of 3 time periods and 2 future greenhouse gas emission scenarios. The tool also provides information on how climate change may affect crop development timing and crop irrigation needs. The specifics on how the models were developed can be found in the Documentation tab. And now let's take a look at a real-life example of how this tool might be used. Jennifer has a small fruit operation in Sunny Slope, Idaho. She's heard that almonds have been grown on a nearby experimental farm and is interested in exploring putting in a small block of almonds on her farm. As she begins to explore whether the climate would be suitable for almonds on her land, she decides to check out the crop suitability tool. She selects her location and zooms in on the map to more specifically choose the location of her farm. She selects suitability as her analysis and almonds as her crop of choice. And because she is considering almonds for the future of her farm, she selects the 2010 to 2039 time period and the business as usual or higher emissions scenario. Jennifer is not planning to be reliant on almond production for income and is only interested in trying out something new. So she selects 5 out of 10 years for her crop risk tolerance, meaning that she would be okay with seeing successful crop production with no problems from adverse temperatures in only about 50% of years. Jennifer sees that currently frost is the primary limiting factor to growing almonds on her farm. Occasionally, summers are sometimes too cool as well, meaning that not enough heat accumulates for the crop to fully mature. However, under climate change conditions, the frost risk will decline and summers will warm, meaning that almonds may see success in about 63% of years, or 6.3 out of every 10 years on her farm. Jennifer decides to be a little more optimistic about the future and selects the reduced emissions scenario, RCP 4.5. Under these conditions, she sees that almonds on her farm would see success in about 56% of years. Thinking that climate change is likely to alter the timing of bloom and maturity for her current cherry orchard, Jennifer decides to see what is projected for phenology as far as changes on her farm. She selects phenology as the analysis and cherries as her crop. Now she is able to see that the timing of budburst, bloom, and maturation will all be earlier going into the future. This is true under both RCP 4.5, or the lower emissions future, and a bit more so under RCP 8.5, the higher emissions future. Lastly, Jennifer is curious what the water demands for her farm will look like under climate change. She selects irrigation from the analysis menu and sees that although water demands will increase, the average annual water needs are well within her ability to irrigate. Having explored the suitability tool, Jennifer decides to further research the idea of planting a few almond trees on her farm with her farm advisor and others who are familiar with her farm's soils, microclimates, management practice options, and farm needs. The specialty crop suitability tool is one of the tools in Jennifer's decision-making toolbox and has served her as a starting point for making climate-informed decisions about the future of her farm.